In this example, we're conducting a hypothesis test about a population mean. And we want to test the claim that the credit ratings are from a population with a mean that is equal to 700. So the null hypothesis is that mu, the population mean, is equal to 700. The alternative hypothesis is that mu is not equal to 700. Now, how do we conduct this hypothesis test in the calculator? I click on Stat. All right, let's try that again. Stat, and the left arrow to get to tests. And now we're going to do a t-test, number 2. We're not going to be doing z-tests ever. So we're doing a t-test. That's number 2. And the first thing that I have to choose is the input, whether we're using data or stats. In this problem, we're using statistics. We don't have a list of data, and we'll see in the next video what do you do if you do have a list of data. So that'll be coming up. All right, so I chose stats. Make sure that that's highlighted. You can see it makes a big difference as to what you have to enter. Next we have mu0, which is again the value from the null hypothesis, very similar to when we were doing the hypothesis test for proportions. So I enter 700 and I go to x bar. Now that was given very clearly in this problem. You're told that x bar, which is the sample mean, so it may read the sample mean is equal to 660.3 or whatever it is in that problem. So 660.3 is our sample mean, and the standard deviation of the sample is 95.9. N is the number in our sample. In this problem, that's 18. Now, this is a two-tail test, so we've already chosen the correct test here. And we go down to draw and press enter. As long as draw is an option, I'm always going to choose it because we're given the test statistic on the left and the p-value on the right. Now, the test statistic is a negative here, but even if it had been positive and it was this value here, they still always put the test statistic on the left-hand side. So this doesn't really relate in terms of position to the whole graph. All right, so we have our test statistic is negative 1.76, rounded to 2 decimal places, and our p-value is 0.097. For this problem, the significance level is 0.05. That's what we see most of the time. Can vary, but most often we see 0.05. Since our p-value is greater than 0.05, we fail to reject the null hypothesis. And that concludes our test.